Alright, welcome to today's video. On today's video, we're going to be looking at multiple integrals. Right, so we have our basic integrals, the definite and indefinite integrals, but then we have the multiple integrals. So now, just like in the videos already on the channels on definite and indefinite integrals, now when we have integrals, we have something like this. Then we can have x dx. So that means we are integrating x with respect to dx, right? So this is an indefinite integral. Then a definite integral will take points from A to B, right? But now when we talk about in multiple integrals, then we're talking about integrating a function more than once, right? So we're going to be integrating it from a to B and then from C to D of a particular function. So we have x here and then we have the x, the y, right? So this means that we're going to integrate x with respect to the x, then whatever we get, we're going to also be integrating it with respect to the y. This is multiple integrals, but we're dealing with definite integrals, right? Because here we're having our points A and B and C and D. Right. So I'm going to explain the concept of this so we can see how we use it to apply it to questions. Now, if we were to solve this integral here, the integral of x from a to b dx, then we will just have x 1 plus 1 over 1 plus 1 plus c, right? But because it is a definite integral, we're not going to be adding our plus c. So here we integrate from b to a, and then we have x squared over 2 from b to a. So we have this and then we impute our values. So we'll be having b squared over 2 minus a squared over 2, which will give us b squared minus a squared all over 2 as our final answer. So we have this. This is basic definite integral. So now when it comes to solving questions under multiple integral, we're still going to use the same process, but we take them one after the other because we are having two integrals, right? For multiple integrals, we have double integrals, we have triple integrals, and we haven't go as far as having up to four different integrals in one question. Right, so we're going to be looking at this double integral. We're going to see how we can do it. So now what we're going to do here is that we're going to first pick this part of the question, integrate it, and then we now integrate with respect to dy here. So the first part is going to be b of a, b to a, I mean a to b. Then we have right integrating x dx. This is what we're integrating, right? We brought it out from this. This is a double integral. So we brought it out from this. Now what we're going to do is that we're going to integrate this, which we already did earlier, and we go b square minus a square all over 2, right? So this value is equal to this, So what we're going to do now is we're going to plug this value here in place of this value here. So we're going to be having the integral of c to d, then we're going to be having b square minus a square over 2. But now we are integrating with respect to dy, right? With respect to y, because we have dy here, right? So this first one thing I need you to understand is that the first value that you have here, let me change the first value that you have here, this dx is going to take this one, the first integral sign, right? While the second one, dy, is going to take the one outside. So when you integrate for dx, make sure you are taking the first one, right? And then when you integrate for dy, make sure you are taking the second one, right? So now if we're integrating this, because now if you look at these expressions that we have here, you can see that there is no y. So that means that this is going to be a constant because remember, we are integrating with respect to dy. So that means with respect to y, that means this entire expression is a constant. And all we need to do here is just to add our y. So b squared minus a over 2, then we have times y. So we have this, right? This is the integral of this. Let me clean this so that it is not confusing. All right. So we have this, and then we're taking the definite integral from C to D. So we have this. So we're just going to impute our values for y. Remember, these values that we have here are the values for y. So we're going to be having b squared minus a over 2. Then we're having substituting for d, that's the first one, then minus b squared minus a over 2 substituting for c. So we have this, then you simplify and then you get your final answer. Our final answer is going to look something like this: b squared minus a squared, b squared minus a squared over 2 into brackets d minus c. So this is our final answer. Very, very simple stuff. All you need to do is just identify, just don't make mistake when you are taking dx and when you're taking dy. So now we're going to solve practical examples on multiple integrals. We'll start with double integrals and then we'll solve on double integrals, then we solve on triple integrals. So the first question I have here is the integral. Here we're going from 0 to 3, then from -1 to 2 of 4xy plus 3x squared dy dx. So now you can see that we have dy first, right? So now because dy is first here, it means that this integral from 2 to -1 is for dy, right? Then let me change the ink. So then for dx, then we're having the integral from 0 to 3, right? So now what we're going to do is that we're going to solve for this part. We're going to solve for this part and then we impute it back and then solve for the second part. So we'll bring out the first part. So we have the integral of 2, then -1. We have 4xy plus 3x squared dy. So we're going to be integrating this. Now, integrating this, we're integrating with respect to y because of this dy that we have here. If it was dx, we'll be integrating with respect to dx. So that means any other alphabet apart from y in this expression is going to be a constant, right? So now let's separate this. So we're having 2 minus 1, 4xy dy. I can separate it because of the plus that I have in between them. So I have 2 minus 1, then I have 3x squared dy. So now I'm going to be integrating them, right? The normal way you do your definite integrals. So now here, because 4x here is a constant, right? Because it is not y, right? Any other alphabet apart from y becomes a constant. So we have 4x, the integral of 2 minus 1, then we have y dy, plus here 3x squared is a constant. So we'll bring it out. Then the integral of 2 minus 1, then we have 1 dy, right? So now we begin to integrate. So we have 4x, we're going to be having y squared over 2, because if we integrate y, we get y squared over 2. Then we have our definite integral from -1 to 2. Then we have plus 3x squared. Then when we integrate 1, we just get y. Then we have from -1 to 2. So now we can solve. So we have 4x. Now one thing I want you to understand is that in this expression here, we integrated with respect to y. So it means that these values here, they are y values. You cannot substitute them for x, only y, because we are integrating with respect to y. So wherever we see y, we put 2. So we're going to have 2 squared over 2 minus 1 squared over 2. Then we have plus 3x squared. Then impute our values for y here as well. So we have 2 minus 1. So we have this, right? So now we're going to be having 4x, right? We're doing this. So that's 2 raised to the power 2, that's 4 over 2, which is going to give us 2. Then we have minus, here is going to be minus 1 squared, which is 1. So that's going to give us 1 over 2. Then we have plus 3x squared. Then we're going to be having 2 plus 1. Right? So here we're going to have 4x. We have 2 minus 1 over 2, which is going to give us 3 over 2 plus 3x squared multiplied by 3. So here we're going to have 6x plus 9x squared. So we have this. So that means this expression here is equal to this. And then we can plug it back here. So we have the integral of 0 to 3. Then we have 6x plus 9x squared dx, right? The second one. We're going for the second. We've done the first one now. That's the first part. Now we're doing the second part, which is the second integral. So we have this, then integrating this, we're going to be having 6x squared over 2 plus 9x cubed over 3 from 0 to 3, right? Then we'll plug in our values. So we're going to be having 6. Okay, let me just simplify first. So we have 3x squared plus 3x cubed. Then we have from 0 to 3. And then we can plug in our values. So we have 3 here, 3 squared plus 3 cubed. Then minus, we have another bracket. So we have 3 here, 0 squared plus 0 cubed. We close this. So automatically everything here becomes 0. So here we're going to have 3 times 9, which is 27. Then here we're going to have 3 times 3 is about 3, which is 81. 81. 3 raised by 3 is 27. 27 times 3 is 81. Then we have here minus 0. So 27 plus 81, and that will give us 108. So that means that is our answer for this particular double integral. Now, we could also do this by taking the x first. Now, if you notice, we took the y first, then we took the x. Now, we could also take the x first before we take the y, right? But we must make sure that we take the x alongside its integral, right? Its integral and the limits of that particular integral, right? This is what I mean. Let me clean this off. So now we have done it by taking the first one, right? So now we can do it by deciding to take the x first before we take the y. And we'll still arrive at the same final answer. So now if we are taking the x first, let me change the, if we are taking the x first, we're going to be having 3 and 0. Remember I told you that this one is for dx, right? Then this limit of -1 to 2 is for dy. So having this, then we're going to be having 4xy plus 3x squared, then we have dx. Now we're going to integrate this. Remember, for this expression now, we are integrating with respect to x, right? So now we're going to have 4xy plus the integral of 3x squared dx. Let me include the dx here. So now we're going to be having, because now x is the variable and y is a constant. So we're going to be treating y as a constant. So we have 3, 0. Here we have x dx plus, here now we already have, the only constant here is going to be 3, right? So we have this because we are integrating with respect to x. So we have x squared dx. So we have this. So now we just integrate. So we have 4y, then we have x squared over 2, then we have from 0 to 3, then we have plus 3, then we have x cubed over 3, then we have from 0 to 3. So we have this, and then we can just solve very easily. Remember I said, like, when we're doing the first one, I told you that the limits that you are carrying, right, it is only for that variable. So now this one now we took with respect to x. So that means 0 and 3 is only for variable x. You cannot substitute it for variable y, right? So we have 3 squared over 2 minus 0 squared over 2. Then we have plus 3. Then we have 3 cubed over 3 minus 0 cubed over 3. So we have this. So we have 4y. Then this is going to give us 9 over 2 minus 0. Then we have plus 3. This gives us 27 over 3, which is 9. Yeah, so this is 9 minus 0. Right? So let's clean. Let me rub off this place so we can finish solving. All right. Okay, so we have 4y multiplied by 9 over 2 plus 3 times 9, which is just 27. Right? So this will give us 4y times 9 over 2 is going to be 18y, then we have plus 27. Right? So now this is what this is equal to. So now we're going to plug it back and then solve for our dy, which is the limit of dy is -1 to 2. So we have 18y plus 27, then with respect to y. So now let's solve. So we're going to be having 18y squared over 2 plus 27y from -1 to 2. And this is going to give us, we're going to be having 9y squared plus 27y from minus 1 to 2. Then we impute our values. We have 9, 2 squared plus 27 multiplied by 2, right? So we have this. Then we have minus. Then we're going to be having 9 minus 1 squared plus 27 minus 1. Right. So we have this. So now 2 squared is going to give us 4. So 4 times 9, that will be 36 plus 27 times 2, which will give us 54. Then we have minus 1 squared, which is going to be 1. Then times 9, which will have 9. Then minus 27. So we have this. Then we're going to be having 36 plus 54 minus 9 plus 27. So we have this. And at the end of the day, we end up with 108, the same answer that we got from using the initial method. So whichever one you want to do, you use it. Now, the reason why it is important that you know that you can take it from the beginning or you take it from the back is because there are some certain questions that you might need to take it from the back first to make your work faster. I'll give you an example. Now, if for instance we do not have these values, now the values that we have here, we had from 0 to 3 and we had from minus 1 to 2, which is a little bit on the high side, right? Imagine we had values that were very, very simple. One value very simple and the other one very. Imagine we had here from 0 to 1, and here we had from minus 5 over 3 to 4. Then we have something like x square y plus y square x dx dy. Now, one thing that you understand from this is that the x is the first one here, so that means it's going to carry these variables, right? And that means that the y is going to carry this one, right? The last one. Now, if you solve using the normal way, that means taking from here all the way to dx, you integrate this first. It's going to give you a bit of problem. So we cannot have 4 under. This cannot be 4. So let me put 4 over 6. Let me put 4 over 6. All right. So now when you integrate this one, it's going to give you a bit of stress when you are doing your simplification, right? Because now you now begin to impute minus 5 over 3 and 4 over 6. It's going to give you a lot of stress. But imagine you are just imputing 1 and 0, right? You will just easily get your values and then you can now bring it back here and then you solve. So now in this case, I would advise anybody that will be solving this type of question to first go for the dy, right? Because then you'll be integrating from 0 to 1 of x square y plus y square x. And you can easily do this, right? You can easily substitute your values and then you simplify and you get your answer and then you put it here and then you solve. But if you go for this first, you tend to spend longer amount of time. So it will be better that you know that you can take it from the back. Just do not mix it up. If you are not sure if you will not be able to like mix it up, just go for the standard one, that is going from the first one, the front, before you go to the back. But for instances where if you are capable of doing it without making mistakes, it will be better that you identify which limits will be easier for you to get first, and then you easily do that, and then you move to the next one. All right. So for the next question that we have, still on double integrals, we have 4 from 1 to 4, and then from 0 to 2 of x over y. We have x over y plus y squared. Then we have dx, dx dy. So we have this. This is our question. So now, just from the example I gave you before, you know it is going to be easier for you to do from 0 to 2. So we're going to be doing dx first. We're going to be doing this part of the integral first. So we have 2, 0, then we have x over y plus y squared, then we have dx. We have this. So that means we are integrating with respect to x. Now, because of this plus that we have here, let's go ahead and separate it. So we have from 0 to 2 x over y dx plus the integral of from 0 to 2 y squared dx. We are integrating with respect to x. So that means that automatically that 9 and y is going to be a constant. So we can bring that out. So we have 1 over y, the integral of 0 to 2 of x dx plus y squared integral of 0 to 2 of 1, right, dx. Now integrating this, we have 1 over y, we have x squared over 2 from 0 to 2 plus y squared, then we have x from 0 to 2. Now remember the value, because we are integrating from with respect to x, it means that the values of the limit are only going to represent the x value. So we have 1 over y, so we have 2 squared over 2 minus 0 squared over 2 plus y squared 2 minus 0. So we have this. Let's finish our solution. So we have 1 over y, and here we have 2 squared over 2, which is 4 over 2, which is 2 minus 0. Then we have plus y squared multiplied by 2. So we're going to be having 2 over y plus 2y squared. Now this is the value for the first integral. Now we're going to go for the second one, which is 4 to 1. Then we have 2 over y plus 2y squared dy. Now we're having dy, which means that we are integrating with respect to y. Now integrating with respect to y, you can go ahead and still separate it if you want. You don't always have to separate it. I mean, I'm just trying to explain so that you do not get confused. So we have 2 over y dy plus the integral of from 1 to 4 2y squared dy. So we have this, and now we can solve. We have 2 over y, right, basically. So we can bring out the constant. So we have 2, the integral of 4, 1, then we have 1 over y dy plus 2, the integral of from 1 to 4 of y squared dy. Remember, whenever you integrate 1 over y or 1 over x, it always gives you the natural log of that variable, right? So because here we're integrating with respect to y, we're going to be having natural log of y. Let me quickly clean that so we can still have adequate space to solve our questions, right? If you have not watched the videos on integral, you need to refresh your memory on integrals. I would I would like to advise you to go and visit the channels on and check out the videos on integrals, definite and indefinite integrals, and even the exponential and trigonometry integrals, so you can refresh your memory before your exams. So we have from 1 to 4, then plus 2, then we have y cubed over 3 from 1 to 4, and then we impute our values. Here we have 2, then we have the natural log of 4 minus the natural log of 1 plus 2. We have 4 cube over 3 minus 1 cube over 3. So we have this. Then here we have 2, the natural log of 4. Now the natural log of 1 is 0, right? So we have minus 0. Then we have plus 2. Then we have 2. Then we have 4 cube, which is going to be 64. Then we have 64 over 3 minus 1 over 3. So we have that. Let me roll off this other side so we can solve and get our final answer. All right. So here we're going to be having 2 natural log of 4 plus 2. We have 64 over 3 minus 1 over 3, which is going to be 63 over 3 basically. So we have 2 natural log of 4 plus 2 times 63, which is going to give us 126. All right. So 2 times 63 will give us 126. Then we have over 3. Now, natural log of 4. Sorry. Now, 126 divided by 3 is going to give us 42. So we have this. So this could be your answer, or it could also be in another form, right? Because we can express 4 as 2 raised to the power 2. So we have 2 natural log of 2 raised to the power 2 plus 42. Then these two can come to the back just like our indices, right? So we have 2 times 2 natural log of 2 plus 42. So we have here 4 natural log of 2 plus 42. So this could be our answer. It's either this or this. Whichever one you see in the options, they are both the same thing, and then you pick your correct answer. That's all for double integrals. Now, triple integrals also take the same exact method, right? It's just that you have one extra integral at the back. So it's nothing too much. It's nothing too special, nothing too difficult. You still solve it the same exactly. But I'm going to be taking one example and then we'll end the video there. One example on triple integral. All right. So the question I have here, I have the integral from 0 to 1, integral of minus 1 to 2, and integral of 0 to 3. Then I have x squared plus 2yz plus z cubed. Then I have dz, dy, dx. Now, what does this mean? It means that for dz, this is the limit. Then it means that, let me change the color of the ink. For dy, this is our limit, and then for the x, this is our limit. That is what it means, right? Because the first one here, we take the first integral, the second one we take the second integral, and the third one we take the third integral. So it is that simple. So now that we understand that, now I want you to check all the limits. Which one is the smallest? Which one do you think is going to be the easiest for us to do? From 0 to 1, yes. So that means it will be better for us to do from 0 to 1. So that means we're going to be doing with respect to x first, and then we now plug it in the other integrals and we solve. So we're going to be doing this here. So we have from 0 to 1, we have x squared plus 2yz plus z cubed. Then we have dx. So we have this. So now we're integrating with respect to x, right? So that means that every other variable here, we take it as a constant. So x cubed over 3 plus 2xyz plus xz cubed from 0 to 1. So we have this, and then we just impute our values. Remember, when you impute 0, everything will automatically become 0. So let's just impute 1. So we have 1 cubed over 3 plus 2, 1, yz. You can see that I'm not substituting for y and z because I'm integrating with respect to dx. So that means that every other variable here have will not will not have a value substituted for it. So we have this, we have 1 over 3 plus 2yz, then we have plus z cubed. This is the first integral that we got. So now we can plug it in into any of this, but I'm going to rewrite it first. So what we have left is 2 minus 1 to 2, then we have 0 to 3, and then we have 1 over 3 plus 2yz plus z cubed. Then we have dz dy left because we have done dx. So now you can see we have reduced this triple integral to a double integral, and then we can now solve. Now if you look at it again, the easiest one to do now is going to be from 0 to 3, right? So we're going to go for that next, and from 0 to 3 is for dz. So we're integrating with respect to z. So we have from 0 to 3, 1 over 3 plus 2yz plus z cubed dz. So now integrating, we're going to be having 1 over 3z plus 2yz squared over 2 plus z raised to the power of 4 over 4, then from 0 to 3. And from here, we just impute our values. Remember, when you impute 3, you get 0. So let's just, when you put 0, you get 0. So let's just impute 3. So we have 1 over 3 multiplied by 3 plus 2. All right, so we're going to be having 2 y, then for z, that's 3 squared over 2 plus 3 raised to the power of 4 over 4. So we have this. So now this will give us 1 plus 2, cancel out 2 here. So we have 9y, then here we have 81 over 4 plus 3 raised to the power of 4 is 81. So we have this. So now we're just going to plug it into the last integral. That's from minus 1 to 2. 1 plus 9y plus 81 over 4. Then we have the dy. That's the last one. So now we're going to integrate, and then we're going to get y plus 9y squared over 2 plus 81 over 4y from minus 1 to 2. And then we just impute our values and we solve. Right? So you can see that this one is going to be more difficult now because we have minus 1, unlike the other ones where we had 0 and we just ignored the 0. So yeah, we're going to be having 2 plus 9, 2 squared over 2. Then we have plus 81 over 4 multiplied by 2, everything bracketed, minus, we have minus 1 plus 9 minus 1 squared over 2 plus 81 over 4 multiplied by minus 1. Sorry, I'm trying to manage the space that we have. So we have here 2 plus we have 2 squared here, that's 4 times 9, which is 36 over 2, which is going to give us 18. Plus here we have 2 times 81, which is 162 over 4. Then we have minus 1 plus, so now minus 1 plus, this is going to give us minus 1 square, which is 1 times 9. So we have 9 over 2. Then we have minus 81 over 4. So we have this, and then we just simplify. Here we have 20. Then we have plus 162 over 4, which is 40.5. Then we have minus 1 plus 4 plus 4.5 minus 81 over 4. So everything here equates to 60.5. Then we have a minus here, so we have minus 16.75. This is, I'm just expressing it in decimal. The answer could be in, so this is 60.5 plus 16.75, and then we have our final answer to be 77.25. The answer could be in fraction, where you have 77 whole number 1 over 4, or you have in mix in or you have it in improper fraction. So that's basically your answer, and this is basically how you tackle triple integral questions or double integral questions.